The subject of data strategy is very important because the essence of everything that involves information technology is really data. Data is the raw material that then generates the capability to deal with the environment in which we operate. The subject tonight will deal with a subject that you will be hearing about quite a bit called transformation. I have to apologize, there are buzzwords that are current in the Washington era, and they always have different meaning. Right now, the buzzword of the day is transformation. Transformation, and I've translated that to you in terms of cost savings and improved performance. It is an attempt to radically change the way how information technology is applied in the federal government. Let me explain transformation in the sense of what history would teach us. And this is a highly simplified way of looking at the history of computing. We started in the 1980s and earlier by basically taking vertical pieces of the business, finance, personnel, and so forth, and just putting it together and making it work as isolated functions. So you would have basically approximately 25 years expended on putting together a personal information system that ultimately reached into all pieces of an enterprise. Then in 1990, there has been a flip around. The discovery was made that just taking personal system and cutting the vertical slices of the business was not good enough, and you have to look at information technology as an enterprise event. And so the 1990s are characterized by what's called enterprise systems. Enterprise systems basically do not look at personnel, but look at the chain of how things get transported through the company. And they may combine personnel, finance, logistics, and merchandising systems. And that lasted us through 1990s, and certainly what we have today. You must understand that from here to here, the information technology has expanded from approximately $30 billion in here to an amount which accounts for over $1 trillion. So there has been an enormous expansion going from here to here. So although it looks simple to you, in fact it isn't, because there has been an increase in the scope of the activity. The challenge that we are facing today is totally different. We have now reached a level of sophistication and complexity where the enterprise view of information technology is not sufficient anymore. And the reason is that if you are operating as a company, you suddenly have internet, and in the internet you have to only work not internally in a corporation or in a government agency, but you must be able to reach out to third-party service providers. Increasingly, pieces of information technology are supplied to you by service providers, as well as you have to reach out outside of the company, outside of the enterprise, into the customers, which means you have to be able to take an order, have it manufactured usually by another company as a subcontract, and then bring it through the internet so that you can deliver 4-5 days later a product that did not exist at the time when the order was placed. So that is really the evolutionary picture of the challenge. And the point I would like to make is that this is vastly more complicated than this or that. And you, as a class that is going to be studying and graduating in information technology, are going to be spending most likely the rest of your career overcoming this kind of a environment and this kind of complexity. Now, let me now plunge into a case study, because to talk about things as a generality does not really give you a full impact. And here is an example of a slice of the Department of Defense. In other words, this is not just the combat part, this is just the administrative part of the Department of Defense. And also, these are major systems. In addition to major systems, there are thousands of small systems. But from a major system standpoint, what you see here is a complexity where the organization of the Department of Defense today has 3,717 systems that we know of. And they have to now take the system which are pigeonholed by finance, by personnel, by function, and then pigeonholed by Air Force, Army, and Navy, and try to put them into some kind of a sensible, integrated whole. So this is the case study that I will be discussing tonight as an example of the issues that are facing somebody who is trying to integrate information technology. The startling fact about information technology in a huge organization, and I must tell you that these numbers are very conservative, but be it as it may, the point is that in the Department of Defense, the best way we know how to identify it, we are spending about $10.8 billion on warfighting. This is the mission of the Department of Defense. In other words, why do you have a Department of Defense? To do warfighting, $10.7 billion. Now, the rest of it is being spent on everything else. And the number which is really the most startling piece, which I'm going to concentrate in my discussion, really deals with management and infrastructure. The cost of the management and the infrastructure, in fact, today is greater than any of the other components. In fact, the cost of management infrastructure is greater than the cost of warfighting. This is very significant. This is a very important insight that you have to understand. When you look at information technology, you always have to ask the question, how much of this information technology is doing any good? And how much of that information technology is just the infrastructure? And what I would like to submit to you, the Department of Defense has grown by adding infrastructure to each of the thousands of information systems, and just adding infrastructure, and the infrastructure is eating up the Department of Defense alive. And that is then the question that needs addressing and needs resolution. As you could see, logistics, human resource, finance and administration take a significant piece. These are billions of dollars, 2.3 billion, 1.8, and so forth, adding up to an unbelievable amount of money, which is $30 billion. You must understand, I don't know whether you can visualize what $30 billion is, but the largest computer budget in the private industry is $3.5 billion. So this is almost 10 times greater than the largest private industry budget. Most private industry budgets are in the hundreds of millions or tens of millions. So we are dealing with here with an enormous operation here, which is clearly, in terms of information technology, the most complex organization and most complex information management problem in the world. Now, I made quite a point of the fact that the infrastructure is eating up the system. In other words, as you grow the system, you have to put in more and more money into the infrastructure in order to support it. And so I would like to explain to you what I mean by infrastructure. Infrastructure is basically the foundation, which is governance, systems engineering, standard security strategy, metadata, communications, and computing. The gray stuff that you see here is going to be there regardless what the Department of Defense does. In other words, the gray stuff is going to sit there the day peace breaks out, everybody loves everybody, everybody declares disarmament, and there will be no war. Of course, it's not going to happen, but at least you have to start thinking about the idea of a information organization that exists without any work to do. This would be comparable in a hospital. What would be the cost of the infrastructure of a hospital, for instance, when there would be no patients? That would be the fixed cost of having computers in place without any patients, without anybody coming in with even for an aspirin. So with that view, the real point is, how big should the capabilities and the applications be as compared with the infrastructure? If, in fact, this is greater than that, that is not acceptable anymore, because we just don't have the money to support that. So the question then is, how do you thin down the environment so that the infrastructure, in fact, shrinks? Well, why do we then need an infrastructure? And this is just a notional idea. Let me just say, the real diagram like this would go for thousands and thousands of pages. It would be a set of boxes connecting to another set of boxes, connecting to another set of boxes, on and on, continually changing. As you go towards an enterprise environment into an internet environment, the relationships between applications grow, and you have to grow more and more lines from one to another. Now, the problem that arises when you start connecting the boxes in what I consider data pollution. Now, this is a very important concept which you really should pay attention to. And what is data pollution? There is a, by the way, this is a small example from, I've just extracted from a record. And what it shows is that some of the data doesn't conform, is not complete, is inconsistent. For instance, here is Boston, Maryland, which is inconsistent. There is no Boston in Maryland. Then you have duplication. This duplicates another record. And then there's a question of integrity. Here you have fields, records that just don't make any sense. What I want to convey to you in this huge complex of thousands of boxes talking to one another. Each box has some degree of information data pollution. And it is the inability of the system to make sure that the pollution is taken care of that explains for the fact that systems, as they become more and more complex, in fact, having more and more errors. As systems grow, as complexity grows, errors creep in. And we have now reached a stage of development where it is almost impossible to design a system that doesn't have errors. And the reason is that the system has gotten so big and so complex that the individual pieces have elements of data pollution. So instead of cleaning up, which is hard to do, people just build another system and another system, and then build another system to take care of another situation, meanwhile leaving the old system in place. Another way of illustrating data pollution, perhaps, is by taking, and I take a sample of a record which has 158 names, and said, well, let me look at the makeup of those files and just see what is the problem. And what you see here is interesting. Identification number, well, that's unique. But then you have things like title, where 43 things are correct, 115 are inconsistent, duplicate, or non-conforming. The zip, by the way, did you know there are at least 25 different ways of writing a zip code, including incomplete zip codes? So you really have to understand that unless you have tight control over the elements of the data, you are going to go in with a file that has a whole number of incomplete, inconsistent number. For instance, Social Security number. You thought it would be easy to define the meaning of a Social Security number. Well, the answer, no. You can write it with dashes, without dashes. You can write it with suffixes. You can preface it in many different ways. So phone numbers, same thing. Phone numbers can be expressed in many different ways. So given that, you discover that if you want to now put together the system which individually have polluted data, and you start stacking them up, you cannot get interoperability, because when you rely on another system to feed in information into a third system, you discover that the format in which the data is transmitted varies and differs. And this is what you people spend lots of your time on in terms of maintenance. It's the whole question of maintaining integrity. In fact, and this is a sort of a funny thing, if you want to create interoperability, and by the way, this is a very limited case. This is only 2, 6, 7, this is 11 computers. Can you imagine a system in the Department of Defense that most likely has somewhere between 50 to 80,000 computers? So now you want to connect them, and you connect them so that the stuff which is inside each of the computers may or may not be polluted. Well, you cannot get interoperability. You cannot have these things work. You cannot have these things work without intervention. So the question is fine. This is the problem. This is a statement of the problem. The question then is, well, what is the way how I'm going to work my way out of this kind of a situation? And this is the outline of my next 4 lectures. Today's lecture is on data strategy. In 3 weeks, I will be talking about net-centric operations. I will then talk about enterprise services. And lastly, I'll be talking about the thing which is the killer. Namely, as you start adding more and more of your information technology into the internet is being basically a dangerous place to be. The internet is unreliable and subject to compromise. So here are my 4 topics that I'll be discussing. Let me concentrate today on data strategy. And since the subject is enormous, I will concentrate today on the business area rather than on warfighter and intelligence. The problems are pretty much the same, but let me concentrate just on business mission area. Now this is a little complicated, but would you please bear with me to look at the way how the Department of Defense is proposing to attack the environment. The underlying issue in the business area is to strip out from the system and from the application, from the thousands of applications, what is called a shared communication, computing, enterprise service, and information assurance environment. Right now, these things are running down for each individual application. In other words, each application has its own communication system, its own network, its computing infrastructure, its core services, and there's a whole list of core services, and its own information assurance. In other words, the system is designed the way we designed systems during the Cold War, where every application was standing pretty much on its own. The objective now is to create an environment where these things will be common and shared, and therefore all you will do is to develop for the transformation just the upper layer. In other words, remember I explained to you the difference between infrastructure and the applications. What this says is the applications will stay with the customers, with the Army, Navy, Air Force, but the infrastructure, which is communications, computing infrastructure, core services, and the information assurance is going to be shared across. Now this is a huge, huge change in direction. This means that instead of having to support thousands of infrastructures that support thousands of applications, you're going to end up with a small number, and we don't know how many, but certainly a small number of infrastructures supporting hundreds and hundreds of applications. Now, the thing that I highlighted here in the red is a core enterprise service. The core of the enterprise service is a particular capability called a data dictionary. In other words, in order for the various systems to be able to extract out of the infrastructure the data, there must be a uniform data dictionary. And so I'm going to be spending now quite a bit of time. But remember, the key to tonight's presentation is the idea that there is such a thing as a data dictionary, and the data dictionary is then becomes the unifying concept which binds together the ability to have a shared infrastructure supporting thousands of applications. Now, let me just give you some mumbo jumbo. This is very important. Policy is very important. The underlying technology for where the Department of Defense is going is so-called net-centric data strategy. And it has a set of directives. It provides a foundation for managing the data and tags all data with metadata to enable discovery. Now, I don't know if you have heard the term metadata. Metadata is something that you absolutely have to learn how to understand. Metadata is data about data. It is a descriptor of data. It's an abstraction. And that metadata is then becomes a tag under which the individual data gets pulled in. There's a whole list of interoperability. I don't want to bore you with it. The only thing what I want to point out to you is that the directions of the Department of Defense with regard to policies of interoperability are well set, well defined, well explained. So there is no reason why, from a policy standpoint, this should not be executable. Of course, the problem is doing it, but that is not the subject of tonight's discussion. So what is then the objective of a data environment? And that is really, and I try to skinny this down as much as possible, to deliver an environment that enables many-to-many information exchanges and enable access for sharing of information. That means that you must be able to go into the data dictionary, look up an application, take the data, and transform it so that it can be then moved into a new environment. That's a very tough problem. It's a software issue, but the issue of data translation based that is driven by the data dictionary then becomes the key enabler. So what do we want from all of this thing? We must have data that is visible, accessible, and understandable. You cannot have data anymore hidden in a definition of a particular application. The data must be available when and where needed, must be tagged for discovery, must be registered to description, must be distributed, must be organized for sharing of vocabularies, and must be archived for analytic needs. So you now suddenly are elevating data from being submerged into the application to data which is now part of the entire knowledge of the Department of Defense. Perhaps a piece of graph would perhaps represent what metadata represents. You have a metadata registry in the center, the hub of the system, and out of that thing you can then extract services, people, content discovery, and so forth. That is the picture for extracting data out of the environment. So now let me go at this thing once more, because you obviously seem to be glazed over here, or wondering, or puzzled, or what have you. But let me try once more, okay? According to the IEEE, data engineering is concerned with the role of data in the design, development, management, and utilization of information system. If there is one career that you guys ought to pin your hopes on, and I'm giving you career advice now, it is on data engineering. Data engineering is going to be the most sought after systems engineering skill. Data engineering, the ability to take data and re-engineer it for database design, for knowledge extraction, for language description, for security, and for engineering services, is the key, is the ticket, the winning ticket for the 21st century. And I think that you ought to sort of pause about it. And if you remember nothing about this lecture, would you please do me a favor and remember that getting involved with data and data management is the way how you can advance your career. The whole mechanics, how you do this, is fairly complicated. All I want you to understand is that it involves the issue of namespace and information resource. It involves going into a data metadata registry and then extracting out of it information. I don't want to bore you with the positions. There are several jobs on this diagram. For instance, you have the namespace manager, and then you have somebody who is a registry administrator. So there's a whole set of new jobs to be had in managing data, because the shift, you are shifting basically the cost of systems development from writing applications to moving it into data management. That means that the information resources have to be registered, controlled, and the authority for enforcing the data into the system becomes very important. What is happening, as I see it, in the scheme of how you do system development, the database managers move up in the importance of systems architecture. See, much of the stuff that usually people are concerned about, which is data centers, communication, and so forth, are taken care of as if utility. The issue really is, how do you then mold the thing together into something that works? I want to mention very briefly XML. XML is the language, it's a formal notation. How many of you have studied XML so far? Oh, wonderful. Okay. So you are well on your way. I think XML is the key to the environment for tagging the data. And that means that that is the beginning of namespace management and namespace environment. Now, so that it is understood what we are talking about, I want to go back once more. I think this is the third time we're going around, but I will do it anyway. You know, why all this fuss? Why should I even worry about all of this? Well, the problem is really that when you go inside any large organization, whether it's medical or whether it's defense or whether it's in a private company, you will find that the data is buried in zillions of forms. And here are just a few. And they are in different databases, they are in different flat files, they are in SAP, they are in IBM. And then, by the way, these are abbreviations because each of these things have then dot suffixes. So you have variance upon variance. I would venture to guess that in the personal area alone in the Department of Defense, data, this is apart from data pollution, data could most likely be found in 2,000, 3,000, 4,000 different formats. And now you have to go and take all of this thing, put it in XML form, so that even if the data originally is in IDMS and CICS and VSAM, in fact, it can migrate and can be used until it can be consolidated out. Again, data is found in zillions of forms. Microsoft Word, and those of you who know Microsoft Word know that Microsoft Excel spreadsheet XP is not compatible with Microsoft 98. I mean, these are simple, here it is just one item, but in reality, they are just variance upon variance. This is what's causing the excessive infrastructure cost. It is the proliferation of formats and definitions and naming conventions. This is my 5th time I'm going to make the same point again. This is an example of data pollution, and I just fished this one out, and I said, well, this is interesting. A question was asked on a questionnaire, you know, fill out a form. And the question was, citizen. 9,451 said US, 228 said yes, 158 said USA, 128 said U.S.A, and so forth and so forth. 2 guys answered green card. 323 just didn't answer the question. Now, if you have a system that is loaded with this kind of stuff, you cannot use that system. In other words, this is not a system that you can use. Yet this is typical what you are going to find. You will typically find this kind of stuff all over the place. And so what you're going to do, you are going to put in edits, and you're going to put in corrections, and you're going to put in filters, and so forth. And when you would put in edits and filters, they are just going to be error prone, and that is just going to spin you around and around and around, increasing your infrastructure costs. Now, this is my 6th attempt to explain the same thing. A chair is not a chair. You see, a chair is an object that has a back, has 4 legs, and a seat. But that's not good enough. So now you have to get into the question of taxonomy. See, I'm now adding complexity to the whole issue of data identification, where you now have to explain really what do you really mean when you say a chair. Now, I give you a simple example of chair. There are more complex phenomena. So all what is necessary for you to understand is the need to get a good appreciation of what it takes to get the data right. So those of you who are looking for jobs can examine the slide. These slides will be available on the web, so I don't want to go into detail. But in order for the data dictionary system to work, there has to be a very deliberate, progressive sequence how these things are done and how data is then released to the system development organization to be included and incorporated into the data environment. What we really have to do is we have to extract data from the mess we have today into a record of reference. And the record of reference is basically an engine, a very complicated engine that takes legacy data, citizen data, which says USA, US, green card, and translates it or ejects it for correction, so that you finally get into a pure environment. And the migration from here to here is the path of data-centric management. In other words, let me repeat it, the objectives of data management is to take data out of records of origin, such as it is, the thousands of applications with thousands of sources of pollution, and move them through a very deliberate process so that you arrive at a record of reference that can be then processed and be distributed for multiple applications. Let me give you an example. This is an actual case. Here's a case where we have 185 applications and 40 databases. We are going to go on the first go-around to 42 applications and 2 databases. You must understand these 42 applications actually do more than these 185. What you see is very interesting. These are metrics. Here are examples of the kind of data requiring corrections. 2 billion transaction corrections a year. And here are defective inconsistencies. What I want to point out to you, the existing systems are horrendously expensive. The inaccuracies which exist in the existing system are very costly. Once you can purify it and reduce it, you suddenly can reduce the annual cost of defective data from 287 million to 2 million. You'll never get perfection, but you're talking enormous economic advantages from data management by eliminating the errors that are permeating the system, that are polluting the system, and that are slowing the system down. I'll now conclude with a different example. Close air strike scenario. This involves 5 personalities, special forces, forward observer, a loitering, FA-18 and Aegis Tomahawk, a UAV, and the command authority. This is a military example. To do close air support, you need all of these things to work together to find an aircraft capable of close air support, given coordinates. Now, this is a situation that happens in Iraq every day, hundreds of times. So this is not a theoretical example. This is a real example. It may look very simple. You have a target, you have a command authority, and here are the possible weapons. In that environment, you now have to decide how you're going to execute this maneuver. What you need is the fact that the UAV and the forward observer has different parameters, different definitions. Therefore, in order for the command authority to make a decision, you need an intermediate authentication process. That means that the UAV has to take their target data, their own position environment, put it into a box owned by the command authority, and therefore bring in all of the pieces in here before the command authority can see what's called a fused picture. I don't want to go into too much detail over this thing. I just want to point out to you the need to have real-time fused systems, real-time reactions. It's very important, very vital, very critical. So let me then conclude. I will make some observations. I'll start with the curse of Genesis 2:7-9. I don't know how many of you are well versed in the Bible, in the Old Testament. According to the Bible, years ago, the mankind had a same data dictionary. That's at least according to the Bible. And therefore, there was nothing that mankind couldn't do. There was only one language, and nothing could be restrained for mankind or what they could imagine to accomplish. So what happened, according to the Bible? You confounded the language so they may not understand each other's speech. And this was called Babel, the curse of what I call of Genesis 2. Problem is that we have now arrived at a universal language with a universal environment, with a new universal connectivity. And now the need to communicate on a global basis has arisen. Now, the question is, why would you want to do this? Well, Adam Smith perhaps said it better than anybody else, is that when he observed what was happening in the world, he basically said the division of labor is limited by the scope of organization. In other words, Adam Smith pointed out that the ability to manufacture things is really limited by the way how people communicate. If they cannot communicate, you are going to get very limited sharing of information. In fact, the whole progress of mankind is based on the ability of sharing information. This is why tribal form of production remained constant for thousands of years, because that's all the information channels could handle at the time. I'm suggesting to you that the scope of an organization is limited by its capacity to collaborate. In other words, if you can organize communications, if you can organize the sharing of data, then you will be able to extend the ability of organizations to collaborate. My conclusion, and this is my last slide, is that if you want to create, based on internet, a global environment for sharing and for cooperation, you must start with a data dictionary. Now, it's not a data dictionary which makes everybody using the same language. It's a data dictionary, as I described to you. It's a data dictionary that uses mathematical notation so that a variety of registered sources of data can be then combined and be used at a cost which is affordable. So with that, I then conclude